Hi, and welcome to day one of a 3-day marathon all about the normal distribution. We already know quite a bit about the normal distribution. We've talked extensively about its shape and the fact that mean, median, and mode all occur around the middle. Most values clump toward the center with some that go lower, some that go higher. What we're going to look at today is the idea that anything that's distributed normally can be recentered or rescaled or both to have a mean of 0 and a standard deviation of 1. And you can see that pictured here. That distribution, folks, is called the standard normal distribution. And folks, there are so many things that are distributed normally that a lot of thought and study has gone into the standard normal distribution. The variable that's on the x-axis, the horizontal axis, is called a z-score. And what it represents is the number of standard deviations, okay, the number of standard deviations that the current z is from the mean. Okay, the number of standard deviations from the mean. As you can see, that z-score can be negative. If we are less than, right, the mean, we'll get a negative z-score because we'll be under the mean. If we're positive, that means we're above the mean and we'll get a positive z-score. This distribution, as you can see, is symmetric, and that makes it easy to use, a little bit easier. The total area under the curve is equal to 1, or you might think 100% if you like. We're going to be solving some probability problems here. So 1 or 100% is the total area under the normal curve. Since it's been studied extensively, we can, with really good accuracy, predict what percentage of data values in a normal distribution will fall at or below a given z-score. We're going to introduce you today to a z-table, which is a listing of all the z-scores from negative 3.49 here. You'll see the ones and tenth digits are the row headings, the hundredth digits are the column headings. So this will tell us about z-scores from negative 3.49 all the way up to positive 3.49. What the information in the body of the table is telling you is the probability that you land at or below a given z-score, at or below a given z-score. So I'd like to have you take a look at this real quickly. Suppose I'm talking about the z-score negative 1.92. If I want to know the probability that I lie less than, and see that would fall in around here, the probability that I lie less than or get a z-score less than negative 1.92, I would look up here on the 1.9 row, reading in the 200ths, because we're 1.92 column, and I would follow that down right here and see that that is indeed a very low probability, 0.0274, okay? And that makes sense when you consider that negative z-score should have a low probability of getting underneath, right? That it shouldn't be easy to get underneath a negative z-score. We're going to use this table several times, so I'll refer to it. You should receive a table like this, or you should have a table like this in your possession right now. And I'll tell you at school to bring it home, okay? What we're going to do next is to use that z-table to find several probabilities. We're going to use it several different ways, starting with this, the probability that we get a z-score less than 1.35. As you think about that, I'm going to always encourage you to draw the picture, and mine won't always be perfect, but 1.35 is above the mean, and I'm just guesstimating where, but we want the probability that you lie less than that. So our table will tell us exactly that. You can see that we should get above half of the probability. Let's check that z-table. Again, you're looking at yours at home, or you're following with mine, and mine is a little bit hard to see. we were looking for 1.35. So here's the positive 1.3 row. The 500ths column is here, and we read down to find that probability, 0.9115, right there. It's equal to 0.9115. Now it's your turn. I'm going to ask you to pause the video and find the probability that z is less than negative 2.23. You can see my work here. I looked on my z-chart. I read at the negative 2.2 row, the 300ths column, that the probability that I get less than that z-score is very low, about 1.29%. Usually I leave these things as decimals. I don't write them as percentages, although many do. Folks, when it comes to a problem like this, where we're asked to find the probability that z is above a given number, the drawing will help us, okay? So we're going to think about this. Oof, that's a bad one. But 0.8 standard deviations on the positive side is here. Or what we want to find, what we want to find is the probability that we lie beyond that. Our table doesn't show above, our table shows below. So we could look up a z-score of 0.8, but what our table would tell us is this part of the deal. Well, that's perfect. If we remember that the area under the whole thing is 1, then we could subtract out the area that lies below 0.8, and that would leave us with what's above. So that's exactly what our plan is going to be. We're going to do 1 minus the probability that z is less than 0.8. Will you do that now? Pause the video and let's find that probability. Here's my solution. I looked up the probability that z could be less than 0.8. That was that 0.7881. I subtracted from 1 to come up with 0.2119 as the probability that we could get a z-score greater than 0.8, 21% of the time about. The next example is going to ask us to work backward a little bit. We're going to use the z-table to find a z-value so that that value of z traps, and I want to draw my picture, traps 32% of the probability underneath it. We know the percentage this time, not the z-score. So you think about this. 32% is less than half, so we're in here somewhere. Again, that's just a rough estimate. And what we've darkened is that 32%. I'm going to go back to my z-table and let's think about this. Probabilities, folks, are found in the body of the table. So we need to look in here as closely as we can. We want to try and get close to 0.32 in the body of the table. I think I've zeroed in on it right in here. I see a 0.3192 and a 0.3228 here. I want to choose the z-score that's closer to my 0.32, and that would be 3228. That would be this one at negative 0.47. That's the z-score that traps really close to 32% of the values under it, negative 0.47. That work backward problem, we look for the probability, we look for the percentage in the body of the table. And then read out to find the z-score. All right, very good. We're going to get to our important topic today, standardizing a distribution. I'd like to remind you that the z-score you find is the distance from the mean divided by the value of a standard deviation. That is, if you think about this, to find a z-score, you'd have to know how far your data value is from the mean, the difference that your data value is from the mean, and if you divide that by the value of a standard deviation, that will tell you, okay, that will tell you the number of standard deviations away from the mean that you are. And that's exactly what a z-score does. It tells you the number of standard deviations away from the mean. It's possible that we can use this formula forward and backward. We're going to use it forward first. It says here that if x bar, that would be the mean, is 550 and the standard deviation is 100, find a z-score for a data value, an x, of 600. Following the pattern up here, following the formula here, z will be equal to the data value itself, 600, minus the mean, 550, all divided by the value of a standard deviation. This would give us, let's see, 50, whoops, that's 100. 50 over 100, or 1/2. Our z-score then would be 0.5. Okay? We found a z-score by finding, again, the number of standard deviations that some data value is away from the mean. You find that by subtracting data value minus mean dividing by standard deviation. In this problem, we're going to use the same mean and standard deviation, but the job's a little bit different here. We're supposed to find x, that is a data value, if we know its z-score. Well, we have a formula for z given here, and I'm going to just rewrite. Z is equal to x minus x bar divided by s. I want this formula solved for x. I need to find a data value. So, being the algebra students that you are, you know your first step would be to multiply by s on both sides. That cancels out the denominator. To get x by itself, you'd then have to add the mean. Now let's recap that here. So if we want to find a data value, we do standard deviation times z and add the mean. That formula and this will allow us to standardize any distribution. Let's apply this now. We're finding x if the z-score is negative 0.045. So x will equal, according to our formula, the standard deviation, which is 100, times the z-score, negative 0.45, added to the mean, and the mean in this problem was 550. Let's do the arithmetic. 100 times that is negative 45. Negative 45 plus 550, of course, is 505. And so, if the z-score for some data element is negative 0.45, under this distribution, the data value would have to be 505, which makes sense. It's less than the mean. That's it for us today. We're going to ask you to get out there, do that U-try as quickly as you can.